In the two distinct acute triangles ABC and DEF, angle B is congruent to angle E. So I have two triangles here, and we have A, B, C, D, E, and F. Angle B is congruent to angle E. Triangles ABC and DEF are congruent when there is a sequence of rigid motions that maps. So, in other words, what this question is asking for is, under what conditions will triangle ABC be congruent to triangle DEF? Well, we can prove triangles congruent when the corresponding sides are all congruent. So that is called a side-side-side relationship. Two triangles are also congruent when there's a side-angle-side relationship, where there are two pairs of sides that are congruent and the included angle is congruent. And then there is angle-side-angle. So two angles that are congruent and the included side is congruent. And then we have two consecutive angles and one non-included side is congruent. And then there's actually one more, and that's hypotenuse leg, and this is only unique for right triangles. But in this problem here, I don't think we're dealing with right triangles, or they don't have to be right triangles, so we're going to be excluding that. So these are the four main ways that we can show triangles are congruent. Let's see if any of the options there matches any of the four ways we can prove triangles congruent. So let's take a look. So angle A is congruent to angle D. So let me use a different color. I'm going to use blue. So A to D and C to F. That's not good, because what this does is it's only suggesting that the two triangles, they don't have to be congruent. They can be similar. So this is angle-angle, right? The two triangles are similar. They can be of different size, having the angles be preserved. That's okay, right? But it doesn't necessarily mean that all the lengths are preserved. So because of that, option 1 is no good. Let's take a look at the second option here. AC congruent to DF and BC congruent to EF. This is no good either. This is actually a angle side relationship. There's no this is insufficient in proving that the two triangles are congruent. So again, this is not good. This is not one of the four ways that we can prove triangles congruent. There's no such thing as ASS. So that's not good. All right, let's take a look at the next one. Option 3, angle C and angle F are congruent, and BC maps onto EF. Okay, C maps onto F, and BC maps onto EF. This works. This is an angle-side-angle. So option 3 works. Let's see why option 4 doesn't work. Point A onto point D, and AB onto DE. Okay, so for option 4, I will need to redraw this. So suppose I give you something like this, where this is A, and this is B, and this is D, and this is E. They're supposed to be of the same length, okay? Because they're telling us that A maps onto D, right? And angle B maps onto angle E. They're congruent. So these guys right here, they're congruent. And the other piece of information was that AB and DE are congruent. So what this does, this actually opens us up to the triangles not being congruent, even though it's very tempting to say that that these two triangles are congruent based on angle-side-angle. We cannot make that argument, because say I extend side EF like so, would the condition still be true, right? Is angle E still congruent to angle B? Absolutely. Is the length of DE still the same as the length of AB? Absolutely. Is point A still mapped onto point D? Absolutely. Are these two triangles congruent? They are not. I have to admit, this question is rather confusing because this was a bit of a curveball here. They're saying point A versus point D. Point A maps onto point D. However, if they just changed the language just ever so slightly and said angle A onto angle D, then yes, this totally would have worked. This would have been ASA as well. But really the answer is option 3 here.